first one is called as depth first search. In the depth first search starts a graph's traversal at an arbitrary vertex by making it as visited. We will pick any one of the vertex in the graph and start the traversal from that point. On each iteration, the algorithm proceeds to an unvisited vertex that is adjacent to the one it is currently in. That means here on each iteration we are just searching for the adjacent node which is not visited. If the unvisited node is available, we just visit that node. In the next step, we start from that visited node again and search for the another unvisited node. The process continues until the adjacent node has no any unvisited edges, unvisited nodes. If there are several such vertices, if sometimes what happens, the adjacent nodes are having more than one which is not visited. In that case, we have to break that tie by arbitrary. Means we have to pick any one of this adjacent node. If you have two or more number of adjacent nodes which is not visited, then we have to pick any one of this node. In our example, we are picking by selecting the alphabetical order of the vertex. In alphabetically, which is smaller, that vertex is taken as the adjacent node. And this process continues until the adjacent node has any no unvisited vertices. That is called as dead end. Dead end means the node which has no any adjacent vertex which is not visited. Whenever we found the dead end, our algorithms backup. It's called the backup edge. Okay. Whenever we found the dead end, our algorithms backup one edge back to the vertex it came from and tries to continue visit unvisited vertices from there. Whenever you found the dead end, we go back to the previous vertex where this dead end vertex comes from. Previous, that is predecessor edge of node of the dead end. Then we have to start from that node again. Okay. The algorithms eventually halts after backing up to the starting vertex, with the later being dead end. Our algorithms actually end whenever we back up to the starting node and the starting node has no any adjacent nodes which is not visited. In that case, our algorithm stops. Now I will explain that concept with some example. Okay, before this one, if I see here properly, our algorithms jump from one node to its adjacent node. Our algorithms jumps from one node to its adjacent node, and this adjacent node to another adjacent node, this adjacent node to another adjacent node, where it goes up to that node up to dead end. One node to another node, we jump up to dead end. We can use stack operation for such problem. If I use the stack here, we can solve the problem of depth first search. Whenever a new node is visited, we just push that node into the stack. Whenever we found a dead end, we just pop it. Whenever we found a new node, we just push it, and whenever we found a dead end, we just pop it. Okay, by this we can solve the problem of depth first search. I will explain with this some example here. Now this is a graph given for example which contain 6 elements A, B, C, D, E, and these are the different edges connected to these nodes. Now I will pick any one of this vertex starting from any vertex, but simplicity I am using alphabetical order, so I start from the A. Now first I will visit here A. Okay, for that one I am using a stack here. For that one I am using a stack here to storing these values. Whenever I visited here a node, I just push it into the stack. Here the number indicates, the first number indicates the order in which the push operation done. Here A1 indicates first I will add the or visit the A, and this second number indicates here the pop operation, the order of pop operation. That means when we have backup 1H. Okay, now see, first I have visited A, so I make it here A1. Okay, then I have 3 adjacent node here, D, C and B. Now if I go in alphabetical order, I can visit A to C like this. Now I am visiting here C. Now to this C we are having 3 more nodes, adjacent nodes, A, D and F, but D is already visited, so I have a choice of D and F. If I go in alphabetical order, I can go to D. Once I visited the D, I have to start from here. Next node, I have to search from the next node here. There are only 2 nodes, A and C, which is adjacent to D. But both of these nodes are actually visited. So this is called as a dead end. This is a dead end here. So I cannot go in this direction because this is dead end. So I have to back up 1H like this way. I have to back up 1H. Now I have to start from here. I have to start from C to the next node F. A and D is already visited, so I have to go to this direction, that is F. Now F is visited here. F is connected to 2 more node here, sorry 3 more node, but C is already visited. E, B, there are 2 options. I will go to B. Now B is visited here. Once it is done, I have to go to E. E is visited. E is connected to F, A and B, which is already visited, so I have to do the backup edge. Now see, this is called the backup edge. Now B is already visited, there is no any other node to visit, so go back. F is already visited all the adjacent nodes, go back. C is already visited all the adjacent nodes, go back. Now we are in A. If you see properly here, there are 3 adjacent nodes D, C, B, which is already visited. So there are no any adjacent node for A to visit. So this is the end of the algorithm. From starting point, we visit each adjacent nodes and come back to A. If this A contains no any adjacent node which is not visited, that is the dead end. So we have to stop the process. So that is indicated by here, stack here. First I have visited A, then C, then D. At the D we found that dead end, so we just pop it. The pop indication is indicated by here 1. First I will pop the D. Okay, then I go to C here. Then I go to C. From C I am searching for the next adjacent node F. That is, I have to push here. Then I am searching for the B. From F I am searching for the B. So I push it here. Then E. At the E we found a dead end. So we back up. So it is popped. Second pop is done at here E. Then there is no more adjacent node in B. So this is also popped. Then this is F is popped. Then C is popped. Then A is popped. The order is given here. 2, 3, 4 order of popping. Okay, like that we are doing the algorithm. Now this is actually a tree which shows how actually the visiting will be done, or how actually the traversing will be done. This solid line indicates the adjacent node which is visited, and this dashed line indicates the back edges. Okay, back edges means we are visit up to A, C, D, and D is actually connected to a back edge. Back edge means the edge here, this one is the edge which is connected to its predecessor nodes, which is not a parent. You see properly here, D is actually connected to A, but A is actually a predecessor, but it is not a parent. C is a parent, A is not a parent. So it is indicated by here dotted line that indicates back edge. Okay, in similar way, if you see here from E to F, from E to F is a back edge, because there is the edge here which is connected to F. Okay, and there is a one more here, E to one more node is there, that is which is not visited here. The edge which is not used is indicated by dotted arrow, sorry, dotted line.